wabarakatuh. My name is Muhammad HAZIQ bin Muhammad ZAKI. My matric number 19258. Okay, now we are going to talk about dimensional analysis. Okay, what is dimensional analysis? Dimensional analysis is the relationship between different quantities by identifying their base quantities. So, meaning that we can test out a prototype by just building a model so that we can save money. Okay, so we are going to talk about the parachute question. Okay, so this is the parachute question. Okay, now we have built a model of a parachute to explain how this dimensional analysis work. So this is the model. Yes, the model work. Okay, so the model is geometrically proportional to the prototype, so that its dimensional analysis will work. So this from the question, we got a diameter of 7 meter, the weight of 1020 Newton, the velocity of 5.5 meter per second, and the temperature of 15 Celsius. So from the table, using the temperature 15 Celsius and the atmospheric pressure of 1 atm, we get the density, the rho is 0.07633 kg per meter cube. Okay, so from this question, we need to find the coefficient of drag force for prototype. So we use the formula F over 1 over 2 rho v square A, and we just substitute this formula. Okay, so the force, because it's vertical, the pressure is vertical, so it is the force of drag is equal to the gravitational force. So it's 1020 Newton. So, and then we just substitute this formula, and then we get the coefficient of drag force to be 22.96. Okay, next B, we need to find the velocity for the model. So we equal the dimensional analysis for the prototype is equal to the model. So we just substitute the formula for Reynolds number for the prototype and model, and we arrange this formula to get the V, and then we just cancel this because it's the same value, and then we substitute this value with 12 because the model is 1 over 12 of the prototype. So the ratio of prototype to model is 12. So we just get 12 and time with 5.5 the velocity, and we get 66 meter per second for the model velocity. So for the C, we want to find the model force. So the prototype force is equal to the model force based on the dimensional analysis, and we get the model force to be 1020 Newton. Thank you. Okay, now repeating variable. We take an example of Reynolds number. Okay, so we list out the repeating variable, and then this is this dimension. Okay, so first maybe we take the velocity. Okay, so put the formula of velocity, and then we eliminate t. So which one has t? Which is density. Okay, so we will divide by density to eliminate t, and we will get L square over m. And then second, we eliminate m. So to eliminate m, we will times with rho because it has m, and then we will get 1 over L. And then we eliminate L. So 1 over L, we eliminate L, we will get 1. So this is dimensionless. There is no dimension. So the Reynolds number would become velocity divided by mu times with rho and then times with L. So that is Reynolds number. That's all from me. Thank you.
Hello, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad MUSTAQIM bin NAZAR. My matric number is 193249. Okay, today I would like to talk about dimensional analysis. What is dimensional analysis? Dimensional analysis is the analysis of the relationship between different quantities by identifying their base quantities. We can test a prototype by building the model so that we can save the money. Okay. We have built a model of the parachute. So this is the model. Okay. So this is the question. From the question, this is the information that we can get. The diameter of the parachute is 7 meter. The weight is 1020 Newton. The velocity of the prototype is 5.5 meter per second. Temperature is 15 degrees Celsius. Okay, for the rho, we can get from table at the atmospheric pressure when the temperature is 15 degrees Celsius. So the rho is 0.07633 kilogram per meter cube. Okay, for the A, we want to find the drag coefficient of the prototype. So this is the formula. Then we just substitute the value. For F is 1020, rho is 0.07633, V square 5.5 square, and A is by 7 square of 4. So we can get the drag coefficient for the prototype is 22.96. Okay, for the B, dimensional analysis for the prototype is same for the dimensional analysis for the model. So we use a Reynolds number for prototype equal to Reynolds number of model. So this is the formula for Reynolds number. Okay, we want to find the velocity of the model. So we can get this equation. Rho prototype over rho model we can cancel because it equal to 1. Because the rho is same as the dynamic viscosity, also same. So we get LP over LM direct LP over LM times VP. For LP over LM, can get from the question LP over LM. L model is equal to L 1 over 12 length of prototype. So we can get LP over LM equal to 12. So we just substitute this equation. 12 times 5.5, we can get the velocity of the model is 6.6 meter per second. Okay, for the C, we want to find the force for the prototype. As we can see, the force of the prototype is same for the model. So the force is 1020 Newton. Thank you. Okay, now I will explain about repeating variables. For example, we take Reynolds number. First, we need to list the repeating variables and unit dimension. Okay, maybe we take V first. Okay, V equal to LT. We need to eliminate T. So we divided with mu. Then we got I square over M. Then we need to eliminate M. We eliminate M by multiple L square over M with rho. So it become 1 over L. Then for the last we need to eliminate L. Eliminate L by multiple it with L size. Then we got 1. It is dimensionless. So the Reynolds number become V divided by mu times rho times L. So this is the Reynolds equation. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aiman Hakimi bin SHAMSUDDIN and my metric number is 192208. So today I will explain about the dimensional analysis. What is dimensional analysis? Dimensional analysis is the analysis of the relationship between the different quantities by identifying their base quantities. So we can test prototype by building a model so that we can save money. We have built the model for this question. So this is the model, and this is how it will work. So the model is geometrically proportional to the prototype. So we proceed to the question. From the question we can get all this information. We can get D equal to diameter for the parachute is 7 meter, weight is 1020 Newton, velocity for the prototype is 5.5 meter per second, and the temperature is 15 degrees Celsius. So we can get the rho from the table for 15 degrees Celsius and 1 atm. So for the first question is we need to find the drag coefficient for the prototype. We know that the drag coefficient for prototype is equal to F over half rho V squared A. So we just substitute all the value to this question. So finally we can get the drag coefficient for prototype, which is equal to 22.96. Next, for the second question, we need to find the velocity for the wind tunnel for the model. So we know that the non-dimension for prototype is equal to the model. So we can use Reynolds number for the prototype and equal to the Reynolds number for the model. The formula is this. So we just, which is rho time with the velocity time with the length, and divide by the viscosity, dynamic viscosity. So we just rearrange the formula to find the model velocity, and then we just substitute all the value. Here we can cancel for the density, the viscosity, and the value for the LP over LM is 12 because the prototype is 1/12. The model is 1/12 of the prototype, so that we can just substitute 12 to this, and we can get the value for the velocity of model, which is the 66 meter per second. Lastly, we need to find the force for the prototype. We know that the prototype is equal to the model, so the force is 1020 Newton. Okay, now for repeating variables. So we take a random number. So we list all the repeating variables, which is LC, V, rho, and mu, and its dimension. So first, we maybe take V. So we need to eliminate T by divide by with mu. So we get L square over M. Then we need to eliminate M by multiply with density rho, which then we get 1/L. Lastly, we need to eliminate L by multiple with LC size, and then we get 1, which is dimensionless. So from all this, we get V over with mu time with rho and time with L. So this is Reynolds number. Okay, that's all for me. Thank you.